Arya, let's start the new one. So let's see where we were last time. Okay, so we have this ball, and this
Goes
ball
up.
follows the way the ball will go when we throw it, and then
But
it will it will also bounce off against the walls.
But in
right?
real life, it doesn't bounce.
Yeah, the real life it will not bounce so much. Even in the bouncy surface, it will bounce sometime, but after a while it will just stop bouncing. But today, what we'll start with, we will start with doing little more fun exercise or fun concept to understand. Okay.
Fun?
Yeah, and then what we're going to do is we're just going to copy this. We'll copy all these things, and we'll write a new one, new file. We'll just paste it all of this, and then we'll just save it as
Turtle 2?
TUT2. Yeah, whatever. TUT. Not turtle, it's more like tutorial 2. Okay.
Tutorial.
Yeah.
Oh.
So what we want to do is we want to have, let's think about like we have like our planet Earth, right?
Yeah.
And then around the planet Earth we have our moon,
Yeah.
right? And why does the moon rotate around the Earth? So maybe try to write a program for that. So what we need for that, we need to have a
big moon.
we need to have two position now. We need to have two position, right? One is the you know we're gonna have the other one, right? We will have one at the center, and then the other as that. This is what we call the let's call it the Earth position. Earth position, okay? And we'll call this Earth POS, and let's put this as somewhere here, right?
That's a lot of variables.
Let's put it here. So the Earth position we want it to be. Let's also put some more variable here for our width of the screen, which we want it to be. Let's say 1000. Okay, we want to see how big that becomes, and the height of the screen is gonna be
500.
maybe we can go to 1000. We're gonna see if it's good enough. Okay, so this is gonna be 1500 and the height of the 1000. Okay, and that's what we're gonna use. We're gonna use the width here.
Wow. You're really not even adding any numbers.
And the height here, right?
Yeah.
Now what we'll do is we want to find the position is of our Earth, and we want the position of the Earth to be in the center of the screen.
That's like 250.
Yeah, so we're gonna just do vector
2D.
vec 2D, and since if we change it, it will automatically take care of changing it. We just use the half of it, right? The width by 2 and the height by 2. So every time we change the width and the height, it will automatically
and we might need a division one. A division function.
This is a divide, right? This will just work fine. So every time we change it, it will automatically make sure that this is at the center, right? Now the Earth position is at the center. So we'll draw the Earth. We want the Earth to be little bigger, right? So let's say radius of the Earth is let's say 100. Okay.
Another radius, two radius variables.
Radius Earth or rad Earth rad. Okay. RADIUS. Let's call it the radius. It's fine. The Earth radius, and we'll put it here. So we'll draw the Earth position. We'll draw the Earth radius. Okay. And is the Earth moving? For our experiment, we'll assume that the Earth is not moving. It is at the center of the screen.
What?
Okay.
But it shouldn't.
No, but it's okay. That's okay. Right now, we just assume there are only two things. We can ignore all the other things, right? Now, what happened with the moon? So let's see the moon has some. Let's say the moon has some velocity. Okay, and moon. What will happen to the acceleration here? What will happen to the acceleration? Acceleration is gravity, right?
Yeah.
So what will happen to the gravity? The gravity will be what?
No, there's no gravity in space.
No, the gravity is there, but so what does gravity do? Gravity pulls you to the center, to the
ground.
Earth, no?
Earth.
So the Earth is so big, and even the moon is far away. The moon will be pulled toward the center of the Earth. So even on moon, the gravity will exert. But then you will ask why then the moon is not hitting us, right?
Yeah.
Why is not? That is what we're gonna learn, why it doesn't hit us. Okay?
Okay.
We're gonna learn that once the program is done. Okay?
Okay.
But you think that, okay, if the earth is getting, if the moon is pulling the earth, just the same way we
Yeah.
crash on the, if it will jump, we'll crash back to the earth.
Yeah.
The moon should also crash back to the earth, right?
No, then the earth would
But- but-
destroy.
Yeah, but we'll see that. But first the question is that, how do we write the equation for our acceleration? Because this is just telling you that the acceleration is down, but this is not the case now, right? The acceleration is no longer down, right?
Yeah.
Let's run the program. Just run the program. What happened? It is going down. Oh, what happened here? Oh, okay. You know what happened here? Because we have our these ones, right? We need to
Yeah.
remove these ones, right? Because the radius has changed, all this because the size has changed, right?
Yeah.
So this is what this
What do you
we need to, maybe if you want to, you can make it the width,
with
and this one becomes the
height?
height, and this is fine, this is 0. So let's just run it now. It will not bounce there, it will just go through the earth. But yeah, it came back, right? Oh, there is still
It's big. It's
no,
big.
this is height, I guess. Ulta, we did the wrong direction, right? Height, and this is the. So, is the screen size good? I think the screen size is fine right now, right? Screen size is fine, right? We have this good enough screen size. So now this is fine, but the gravity is wrong, right?
Yeah.
It should go towards the earth. But how do we find the gravity for the earth? What will that look like?
Gravity for the earth.
Yeah, I mean, it is doing all the kind of interesting stuff, but
What that moon?
the gravity should not be down. It should pull you towards the earth, and you should crash to the earth, right?
So the earth also needs its own gravity.
No, the earth don't need to. The gravity of the moon
Yeah.
should be towards the
Earth.
earth. So how can we make sure
then-
wherever we are, the direction of the acceleration is toward the earth? How do we do that? How do we find the direction towards the earth?
Oh, like from this side of the moon, we have to do like.
Yeah, wherever we are, we should go toward the center of the earth. So if we are here, we should pull here.
Like
If
from
we are here, then we'll pull here. If we are here, then we pull here. So let's do a little bit of exercise to understand that, and then we'll go back to the actual program. Okay. So let's go back to our external, and we will try to understand this problem at our hand. Okay. So this problem can be understood by the fact that we have this graph, and this is the center, right? And we have a point here. So the acceleration should be in this direction. Now if we have the graph, the point is here, let's say earth is here, and this our moon is here, and the earth is here, and again earth is here, and the moon is here. So the acceleration should be in this direction.
Oh, I noticed something in common on the left side. Oh no.
No, but so the point is that what you are trying to do is, you know the position. You want to know the direction of the vector. You want to know the direction of the vector. So how do you find, if you know two position, how do you find the vector? If you are two position, how do you find the vector?
How? We need to find magnitude.
No, so magnitude is the second problem. But let's think about the direction problem. Okay.
I don't know.
So addition, what does addition do?
Addition adds to vector.
Yeah. So if we add this vector to this position, this vector will get this vector.
Yeah.
But we already know the endpoint. So let's say this was A, and this was B, and this was C. So then it was like A plus B, A plus C is equal to B, right?
Yeah.
But we want to find the C. So that means C should be equal to B minus A, right?
Yeah.
So if you minus 2 points, you will be able to get the direction of the vector.
Vector.
What the magnitude is gonna be? Magnitude is gonna be the distance,
Yeah.
right? So if you use the same magnitude, now depending upon how far or how close you are to the earth, your gravity will change, right? Maybe you want that, maybe you don't. Let's do some example. Okay, let's do quickly some examples. So we'll just do some example to
Insert page after.
just do some example to understand this. Let's say your position is, let's say your position is here for the moon. So this is 1,1, right?
Yeah.
And then let's say this is your position for the earth, which is
5,
1 2 3 1 2 3 1 2 3 4.
4,
So this is gonna be
3,4.
3,4, as you correctly said. Now if I do the minus, right? So as I said, right,
1.
if this is the vector you want to find,
So-
then if this was A and this was B, when you add A, this vector C, then you will get B, right?
So C equals A
So
minus
C
B.
should be B minus A.
A.
Now if you do the other way, what will happen? You'll get the same magnitude but different direction.
You get it down.
Yeah, you will get different direction. So instead of gravity, it will actually make things run away from you.
What?
Yeah. So yeah, you can try that out, but yeah, that will what happen. So now if we do this minus, what we'll get? So 3,4 minus 1,1, right?
Yeah.
Which is gonna be equal to 2,3.
3.
So what does 2,3 look like? Does this look like this direction? So we can check this out, right? So we can draw another one. 1 2 3 1 2 and 3. So if 2,3 would look like 2 here and 3 here. So it looks to me the same direction, right?
Yeah.
So right, so this is what you get. Okay, so you just have to separate the 2 points, the vector position vector of 2 position, to get the direction of their thing. Okay.
Drawing is
Now-
not so good, but
Now the another thing to notice is that, as I said, right, depending upon how far we with this point, direction is correct, but the magnitude will keep changing. So we don't want the magnitude. We want to have a constant
Scalar.
gravity. We want to have a constant gravity.
Gravity.
So maybe we want the side to be always 10,
10.
but direction to change. So how will do that?
But then the earth should be same distance.
Yeah, means what I'm
Side.
saying is that doesn't matter where we are, how much is the distance. So let's say this was earth and this was moon, right? In this one, the vector size is more, right? And maybe if this is the case, earth and moon, the distance is small. So if we use directly this minus thing as the acceleration vector, then the problem is that depending upon how close we are to the earth, our gravity will change, right?
Yeah.
We don't want that. Maybe we want this to be this direction to which we want to use, but now we want to make this as a magnitude of 1
One.
unit vector, right? 1.
1.
How will we make that magnitude to be 1?
I don't know.
So to make it magnitude 1, what you can do is you can divide it by the magnitude vector. Remember?
We can divide what?
So if we have the c vector and we divide it with the magnitude of it, we'll get a 1 distance, right?
And that's
So if this guy's length was 5, if we divide by 5, we'll get the unit vector of length 1.
1.
So now to give the example, let's say you have a vector, whose length is, let's say our favorite 3,4. This is our vector. So what is this magnitude of this vector is? You get 3 square plus 4 square
There.
and you do under root,
Yeah.
and this becomes 9
9
plus 16 and this becomes 5. So the length of this vector is 5.
5.
But we don't want the 5 length. We want the direction to be the exact, but we want its length to be
Same.
1.
1.
So what we can do is we have to divide by 5. So what we can do is, as I said, right, this was a vector. To make it a length unit length, what we do is we divide a with the magnitude of A. So
A.
that is gonna be divide 3 comma 4 with 5. So this is just a multiplication, but instead of, but now it's just we are multiplying with 1 by 5. So this will become 3 by 5 and this will become 4 by 5. Now you want to check whether this magnitude is 1 or not. How can you check? You're gonna do the same thing again to check if the magnitude is 1, right? So this is gonna be, if you do it, 3 by 5 square plus 4 by 5 square, and you do the under root, right? You already know. So 3 3 is 9 by 25, and this is 16 by 25, and do under root. You already know 25. This is gonna be 25. This is gonna be 1. So the length of this vector is 1. If you draw this on the piece of paper, so 1 2 3 4 and 1 2 3 4 5, let's say, and the 3 is gonna be here and the 4 is gonna be here. So this was 3 4, right?
Yeah.
And if this length is, if you divide into 1 2 3 4 5, sorry, 4 parts, sorry, not 5 part, 4 part, because the length will be 1 2 3 4 5. So this if this was the actual length, now this 9 by 25, sorry, this 3 by 5 and 4 by 5 will be here. So 3 by 5 and 4 by 5 will gonna be here, right? And this is of length 1. So if we get the length of 1 and we multiply it with any gravity scalar, we're gonna get constant gravity. So that's what we want to learn, and I think you might not have understood it fully, but we want to show it how does it look like, and then maybe after a while you will be able to understand how it kind of works, okay? Because our goal is just to try out different things. Okay, so what we learned is that we want to calculate the acceleration. So earlier the acceleration was constant, it never changed. But now we don't want that. We want the acceleration to be calculated every time we are doing stuff. So the acceleration will be, what we learn is that the acceleration will be minus, right? And do we have the minus operation? No, we're just gonna add one minus. So we'll call it
sub,
most likely sub. Let's try if that is the case, okay? And then this is gonna be minus and this is gonna be minus, okay? And now we should be able to use the minus operator, and acceleration is gonna be equal to earth minus, control, earth minus the radius of the, earth minus the position of the moon, okay? But as we said, we want it to, this will give us some magnitude. It will always point to the center, but it will have some magnitude. So whatever we get from here, we need to.
Why are you putting it in triple?
It's okay, because we just want to make sure that the precedence is correct, right? Precedence. This is precedence, not, this is board mass. Remember?
Board mass. Okay, I got it.
Yeah. So we got the vector, but we want it to be divided by the magnitude. So do we know how to calculate the magnitude? We do not have the magnitude. We do have the, we did not have the magnitude, right? So let's find the function for finding the magnitude. So we'll call the function name as mag, magnitude, okay? Or mag is fine. Mag will just use this, and this is going to be having self. And then how do we find magnitude? We need to do math dot square root import math. I think we need to import math.
What's math?
Import math is an envelope package, right? In the package, just to math dot square root. I think, let's see, math dot sqrt is a function, right? We want to square the, we want to do the square of x, right, into this plus the square of y plus, sorry, not plus, multiply, right? And the square of y, and we should get the magnitude, okay? That should give us the magnitude. X, y, we should get the magnitude. So Okay, so we try to find the acceleration vector. We do minus. Let's do this thing, and then the next step is that we want to make it a unit vector, right? So
Yeah.
this is gonna be equal to whatever the acceleration we found, and Control C, Control V, and we need to multiply it with the 1 by the acceleration dot magnitude.
Mag.
Acceleration dot magnitude.
Mag. It was mag.
Yeah, this will give us the length of 1. It will change the vector to the length of
1.
Now we got this one length, but we want to have a constant acceleration, maybe 10. Maybe 10 is the scalar. We want the length to be always, right? So we need to multiply it with 10. So acceleration is gonna be acceleration into 10. Maybe that's what we want. Maybe 10. Okay.
Okay.
Maybe we'll see. We'll see what can we do with this. But we'll gonna start with 10. So this is how we finally calculated the acceleration, and this is how the. And now let's see what gonna happen. Oh, something is wrong. Oh, we did forget to see what the error was. Oh, we did the earth radius. Why did we do the earth radius? We want to do the earth position, right? Still, acceleration into 1 by is the magnitude not working? Let's check if it's not working. Print acceleration dot mag.
I don't know what happened.
Oh, it's saying none. So, oh, the reason is that we did not return it. We did not.
Darn.
That is the reason why it was not working. Now, if we do the magnitude, it will give us 100. So the magnitude of this is 100. So this is correct. Okay. Now we don't need to print it. We're just gonna go back. We go back. We remove this, and let's run it again. And now what happens? Let's see.
What? It just flew away.
It just flew away. Yeah, it's not coming back. Did we do it wrong? Let's just reduce the velocity a little bit. Let's make it 50, and then this one will become 100. Okay, and let's see what happens.
It's flying up.
Yeah, it seems that the gravity, the acceleration is not working on this one. Yeah, so maybe 100 is what we want to try. Maybe increase the acceleration a little bit and see what happens. Oh yeah, now it is pulling, right? Now it is pulling. Now it's pulling again, right?
Yeah.
Now it is pulling again.
But it doesn't look like a circle, and then it goes up and flies away.
No, that's okay. But do you notice the important part? It is not crashing on the earth. Oh, now it crashed, right?
Yeah.
Now it is crashed. We're gonna see. But so that's why it kind of keep pulling, and then it go. So now we just want a little bit of we just want to make sure that so it is pulling. So the point is that if it's far away from the earth, it pulls, which is what we want to do, right?
Yeah.
We want to understand that pulling should happen, and it's pulling also center also, right?
But it doesn't look really good.
Okay, that's fine. So it's kind of working. When the other thing we want to make sure that so it's kind of worked. The only thing I want to try it out is let's try out different direction. Okay, so if we give the velocity just in up direction, what does the up direction look like? Minus 100, right?
Yeah.
Just the up direction.
0.
Yeah, that's up direction. Well, let's check.
What?
just the up direction. Okay.
And it went up. But that does not look like a circle.
Oh, we have that stupid thing which we don't need right now.
Oh, yeah.
We're gonna ignore this one now. Let's try it out again. So we'll try and we see how the program look like now and what's happened. So we started with the direction of this, like now the upside direction, right? The up direction.
It went down. Wait, why is it still coming back? Oh,
Because of the gravity, right?
yeah, the earth
So-
is pulling it.
Yeah, Earth is pulling it all the time because it is moving in this direction. Even the Earth is pulling, but it will go down, right? Because that's what it is. There is some component to it, right?
Yeah, well, the earth should be blue.
Yeah, we can make the blue Earth. We can make the
Blue earth.
yeah.
Oh, and we need earth color also. Variable. Oh, Daddy, what's a class?
Class. Huh?
What's a class?
Class allows you to. But yeah, so what do you learn here? What is happening? What is the most important thing?
Nothing's crashing into
Yeah,
Earth.
means it doesn't crash on Earth, right?
Yeah.
It because of gravity keep rotating around Earth.
Yeah, but the earth doesn't, like, the moon doesn't go up, down, up. It goes
Okay,
into a
okay. We
circle.
do not know. So, that's what I'm saying, right? It depends upon the initial velocity, how it will rotate around the Earth and where it started, right?
Yeah.
So, but the point is that unless until something is heading straight toward Earth, it will never crash with Earth. If it is it goes like this, it could be possible that start rotating around the Earth only. So you understand what it means?
Yeah.
Suppose something come from the outer space and it's try to come near the Earth, it is totally possible that because of Earth gravity, it will start rotating around the Earth in some path. That's what we learn here. So that's how the moon is. So moon has some velocity and it was near Earth enough because of the gravity of the Earth. It just rotate around the Earth
But how do asteroids crash then?
because they are in the path which will hit Earth. No?
Oh.
They are a path which will hit Earth. So it is up to the path. If some path will hit Earth, but you can see the moon is rotating around. But there is one problem in this formula. You know what is the problem? We are saying the gravity is always pointing toward the Earth, right?
Yeah.
But there is one problem which is called gravity is not constant. It always points to the Earth, but it's not constant. The way gravity works is the closer you are to Earth, the more the gravity will be. The further you are away from the Earth, the less the gravity will be.
Yeah.
That is why, like the asteroids, they are not coming near us because they are too far away. But if you are close enough to the Earth, you will feel the gravity of Earth, right? So the only thing we want to change is we want to change the formula so that the gravity becomes the further you are away from the Earth, the less the gravity. Yeah, so that's what we want to change. But you can see, right, the main understanding here is that, at least you learn, is that no, the object does not hit the Earth, right? The reason is that because the path was like this, so it will change the velocity. Velocity will keep changing it, change the direction because of the acceleration. The direction will keep changing, but it will never hit, right? So that's kind of what the logic is.
Yeah.
So it never hit, right? You should see it is running for so long, but it never hit, right?
Yeah, it's accelerating. The
Yeah.
ball is changing direction. It means
Yeah,
it's accelerating.
but it is accelerating in such a way, still it does not hit the Earth. Yeah, that's what the thing is. So as long as your direction is not straight toward the Earth, you will be fine.
Oh, I want to add another ball straight toward the earth.
That will hit, huh? Then it will hit.
Yeah, but what if it doesn't?
Huh?
What if it
Why will
doesn't?
not hit? You know the math, right?
Yeah.
Math is math, right? Whatever the math say, that will happen. Like it's not whatever or wherever, right? That's not how the math works. Okay. So it is what it is. It never hit till now, as you can see. And if the only thing you can change is now, instead of having this constant gravity, we want to have a gravity which is changing based upon how far the object is. Okay. But yeah, so you
Now it's going in an oval.
it is circling around the earth in a very interesting path.
Yeah.
Its orbit is changing, right? So the point is that you don't know how the earth the moon orbit is. You know what you know is that moon rotates around the earth, but the orbit could be anything. You know, it could be circular, it could be oval, it could be anything, right? And that is the thing I wanted to tell you, that the point is that how the different planets are moving around the sun, or you know the moons, if we don't know, like we cannot see that, right? The only thing we know, they are rotating around us, right? That's what we know. So that was a very interesting topic.
But
So-
the Earth does not look like an Earth. It looks like a black.
Yeah, means that's okay. But hopefully you understand it, and you can see the. I think the one other thing we want to learn is maybe we want to draw the vectors. You know, with this exercise we want to draw the vectors.
But how? We need like this line that appears.
No. So what we want to do is we want to, like, at the center of this thing, na,
Yeah.
there are two vectors, right? The velocity vector and the acceleration vector. The acceleration vector will always point to the center of the earth, and the velocity vector is where the ball is moving. So if it's down, the velocity vector is down, right? If it's up, going up, the velocity vector is going up. And because of the acceleration, the velocity vector is changing, right? So suppose the velocity vector is up, right?
Yeah.
But the acceleration is down. So what will happen? The velocity will slowly, vector will keep going less, right?
Yeah.
Till it start to go down,
Down.
right? That's what the velocity vector does, na? That's what the acceleration vector does, right? So yeah, that is an interesting problem which I wanted to show. So now you understand why the moon is not crashing on the
Earth.
earth, right? So that's
Yeah,
all.
because the moon. Because the moon pulls the.
Yeah, because there is some velocity to the moon which is not hitting to earth, right?
Yeah.
It is different, and that velocity is always make sure that you never come near to the earth. You know, that velocity is saving us, because you know the first law of motion, right? The whatever velocity we have, that always we have. Acceleration only changes the velocity, right?
Yeah, but Earth
So it never hit, right?
Earth would also. Now it looks like the ball is moving in a circle.